So, by the way, I would have a quiz Friday, but because half of you guys are doing a test, I'm going to wait till next week, okay? And you know Monday's off, right? So, yeah, Pro D. So, domain and range, we would normally have a quiz like tomorrow on this stuff, okay? But like I say, we're not because of extenuating circumstances. So it's going to be, I don't want to do it Wednesday, so I don't want to do it Tuesday, so yeah, Wednesday it will be, okay? All right, review. The x-intercept. Taylor. Sorry? Sure. Yep. So I just got to know before I print it, right? Okay. X-intercept. What does that mean? There's an x-axis. There's, not right now, just sit down. Okay, don't worry, there's going to be lots of board space at the end of the day. An x-intercept is where it crosses the x-axis. That's what it means, okay? It has a, what else happens? What coordinate might be 0 there? Look, what's the value of y anywhere on this line? Oh, that's not how I want to write it. Has a y coordinate with a value of 0. Okay? Y is 0 at the x-intercept. Have you ever heard this before? Let's make it 22. At the x-intercept, y is 0. Always, always, always. That's how you solve this. I know you're thinking, God, what does he think? We're retarded? I kid you not, I'll give you this question on the quiz, and a quarter of this class, maybe even more, will not get it. Okay? That's why I'm saying it 23 times. At the x-intercept, y coordinate is 0. Okay. And that, what kind of a relationship would this be? This thing that goes straight? It's a linear relationship. Why? Because it makes a line. Does that seem like common sense? I'll ask that question too, and 8 of you won't get it. I'm serious. Okay? It's like the second hardest question on the test other than that one. Okay? Did I tell you one year I put, like, what's your favorite color on there, and some kids got it wrong? I said, what's your favorite color? That was a question. Some kids got it wrong. They didn't answer it. Yeah, I'm serious. Okay. Yeah. Y-intercept. What does it mean? It means where this thing crosses the y-axis. Okay, that's the y-intercept. It intercepts it right there. You guys ever heard this before? Do you know what x is at the y-intercept? You do? You're having a deja vu? Okay. All right, stick it in your noodle and don't let it leave your noodle. Keep it in there, okay? Plug your ears so it doesn't fall out. Okay. Domain and range. You haven't seen this before, okay? Domain, blah, 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 is the inputs, which is also called the independence, which you guys know mostly as 98% of the time that will be x, okay? There's x. That's the input. We input something, x is 2. What's my output? Y was 4, let's say, okay? These are the independents, right? Y depends on x. This is domain. Write this, because it's just something you got to memorize. This is the biology part of this lesson. Domain is x, so then if you know one, well, what must range be? You must know the other one, okay? Domain is x, is X, and range is Y, okay? Did I also tell you there's a relationship between the amount of coffee I drink and how well my speech is? Okay? Yeah. All right, which one's independent there? This is actually a good example. It's said right one way, and it kind of doesn't make sense the other way. Which one was independent? Which one depends on the other one? Does my speech depend on how much coffee I have? Or does how much coffee I drank depend upon how I speak? The former, right? Yeah, see, it makes sense to say it one way or the other. Does the amount of money you guys make depend on how long you work for, how many hours you put in? Or does the amount of time you put in depend upon how much money they gave you? See, it makes more sense one way than the other, doesn't it, right? They don't give you $800 and say, okay, you need to give me some time. No. You put in the time. I worked 8 hours at A&W, okay? That's how much money I get. The amount of money depends on the time. The independent is the time, right? The independent is the coffee. How I speak depends upon how much coffee I have. Chloe. Catering? It's funny you should say that because we're going to have an example in a few minutes on catering. Hold that thought. Okay? All right. Oh, really? Okay. Well, math is related to English, but yeah, in some cases you're going to need to know which is the independent. What time, if you're ever given time, is that dependent or independent? Okay, how do you know that? Because you memorized it. Because I said it, and you got a good noodle. So a lot of stuff sticks, right? That's how we determine if you got a good noodle or not. Someone says 100 facts, smart kids remember 95 of them, right? If you don't have as good of a noodle, maybe only 10 or 15% of those 100 facts, 10 or 15 facts maybe stick in. That means you need to review it more often. You can still get 95%. Some of us need to put in more time than others. Okay? Anyway, range is Y, or outputs, or dependence. Okay? So, list the domain and the range. What's domain? Okay, good noodle. He's already got it. Everyone's going, well, what? Huh? Did he say that? Like 5 minutes ago? Yes, I did. Domain is X. Range is Y. Okay, so what are the inputs of these ordered pairs? What are the X values of these ordered pairs? Well, that's the first one, right? It's always X, Y. So that's a funny squiggly bracket. My domain is 1, 0, 3, 5, line, then comma, and -3. Okay, those are the X values. Does that seem like ridiculously easy? It'll get trickier. What's the range here? Well, let's use a different color. The range are the Y values. 2, 5, 8. Sometimes they're in the right order. Okay, and 2, I already have it, don't I? So don't write it twice. That's the range. It's not 2 and 2 and 2 and 2. We just want 1, 2. Okay, that's a value of the outputs. Those are the outputs. Those are the dependent values. All right, I'm not going to bother doing that one because it's very, very similar. That's ordered pairs. Here's another relationship. It's a graph, right? Visual. If you like visual, you like graphs. What is the domain here? What are the X values of this graph? What are the values of the inputs? Well, I got this one. Does this one have an X value? Yeah. It's -4. Okay? There's a point. By the way, is this discrete or continuous data? Discrete? Everybody agree? It's just these points. Does the intermediate value have any meaning here? No, because they didn't do it like this, make a line. Okay, that's discrete. So I have this point, that's minus 3. I got that one, that's minus 2. That's minus 1. There's 0. And 1, 2, 3, and 4 on the other side. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There's 9 different points there, right? You see any others that are the x values of this graph? No, that's it. Every single one. All right, what's the range? Kind of got my colors opposite to the last one. All right, what's the value of y here for this point? It's 0. What's the value of y here? 1. What's the value of y here? Well, it must be 2, right? That one must be 3. I'm going up by 1. What's this one? 4. Now I go back down the staircase. What's this one? 3. Do I already have it? Yes. Do I already have that one? Yeah, that's the same y value, isn't it? It's the same height away from the x-axis. This one I already have. That one I already have. I don't want to put them twice. That's it. Okay? So, that's A. This is B. Domain. Let me move this sucker over. Don't you wish you could do that? Domain. All right. What are the x values of this graph? Let's start with this point. What is that point? By the way, you don't want to write this. Minus 4. All right. What's the next point? How close can you get to minus 4, but a little bit, and this is confusing. This is negative, so I'm actually going bigger than negative 4, right? That point there right beside it, what's that? Like minus 3.9? Or is it 3.99? Or is it 3.999? How many nines can you think up, Bryce? Okay, well, I got to write that point, right? That's a point on the graph. Oh, let's go thousandths. Oh, let's go 10 thousandths. All right, what's the next point on this line? 3.9998. How long are we going to be here, guys? Yeah. And you're not going to live that long, are you? Wouldn't that suck? Okay, there must be another way to do this. It's in English. Listen to this. In English, it's every single x point from here to here, right? So everything less than or equal to, because it can be equal to, what's this point? Oh, hang on, not less than, because that's in the positive direction. It's everything, I'm going to write this in English, greater than, that's supposed to be English, or equal to, what's that point? Negative 4, but it can't go past this point. It's everything, all the x values, every single point on this graph up to there. What's that point there? Up to 4. Okay? So, that's English. I don't want English, I want math. How do I write that? X is greater than or equal to negative 4, but up to 4. How do I write less than or equal to 4? Okay? X is sandwiched between these 2 points, isn't it? X is in between 4 and negative 4. So just look here. That says, and you guys, did you get taught the alligator thing in elementary school too? Oh, I want to go over there and I want to release my alligator on that teacher. I just don't like that at all. Anyway, that's fine. If the alligator eats the bigger thing, okay, that works. That's fine. Does this say less than or greater than? That's what we need to focus on. I know x is bigger than the 4, but I need to read that in math. Here's a little trick. If it makes an L shape, it's less than. Okay? So if it doesn't, it's greater than. That says, I'm just going to block up this side, okay? I'm just going to look here. That says minus 4 is less than or equal to x. And I know that doesn't make as much sense as reading it in the Chinese direction. X is greater than or equal to negative 4, right? Everything greater than or equal to negative 4. That's what that says. And it also says x is less than or equal to positive 4. Okay? All right, so does the alligator help us here today? Yeah. Okay, well, if it still works, use it. All right? That's what this says in English. Everything greater than or equal to minus 4. Okay? And up to 4, or less than or equal to 4. This says exactly the same thing as this. This is just a little more concise. Okay, that's how the answers in the book are going to be, so we got to get used to that. Okay? You can write it in 2 steps, but it's nicer to write it just with both of these things combined. Okay? X is sandwiched between this point and that point. Every value of x in between here. Let's go back to A. What if I had like 60 points? Do you really want to write out 60 points? How could I write this in the same form? For the domain here, could I go everything less than or equal to that point and greater than or equal to that point, but x isn't everything, it's just what are these? Integers. Have you seen this funny thing before? I know you haven't. That's Greek letter epsilon. It means x is the subset of. Okay? See how now why this is kind of getting confusing? This says exactly the same thing as this. This is little kid form. This is big kid form. And we're in grade 10. We're big kids. Okay? So again, this is x. That's Greek letter E, which is called epsilon. What's the first Greek letter you ever got in math? Beta you get in Science 10, and alpha too. Alpha, beta, gamma rays, right? Okay. The first Greek letter you ever got? Pi, yeah, okay. If you get up into university, second year, you'll be seeing 20 or 30 different Greek letters. And then if you join a fraternity, and it's called Delta Kappa Sigma, Delta, change in, Kappa, Sigma, that's a fraternity, you know, there's lots. Anyway, there's lots of Greek letters. That's what this means. It means subset of. Okay? Sorry? Okay? That means x is just integers. I'm not actually done with this one here. We're not finished, because does this imply that x is everything? X is the set of, guess what R stands for? Real numbers. That means it's not just whole numbers. It's fractions, decimals, all the irrationals. Hey, look, there's root 2 right there. 1.41. Okay? Everything. And then, to add it a little funnier, you know what the answer is going to look like? X such that x is less than or equal to 4, greater than or equal to negative 4, where x is the set of all real numbers. That's what the answer in the back of the book is going to show for this. What's the really, really important part? Just this right here. Okay? But it might be real numbers. It might be, what's I stand for again? Integers. That's like 1, 2, 3, and negative 1, 2, 3 includes 0. There's two other options. What's W stand for? Whole, which is, what are whole numbers? And 0. Yeah. And then natural is just like, yeah, not 0, right? So if I'm talking about people, if my example was people, not just x and y, well, you know, integers might make sense, I guess, in some contexts. So, but usually we want, like, is it one person, 2 people, 3 people? Maybe it was nobody. Okay, maybe I catered something and nobody came. Nobody liked the food. Possible. But real for people doesn't make any sense. Can you have half a person? No. This would be people. Okay? Half a person doesn't